All right, today we are breaking down an absolutely massive strategy to win the future of artificial intelligence. And this is a plan that weaves together some of the most advanced companies on the planet.
This single quote, it really captures the entire idea here. Total vertical integration. We're talking about a strategy that aims to mash up the power of SpaceX, Tesla, and XAI to solve AI's biggest, most fundamental problems. But to really get just how clever this plan is, we first have to wrap our heads around the monumental problem that's facing the entire AI industry. And honestly, it all boils down to one thing: power. Raw electrical power. Okay, get this. Right now, AI data centers are already eating up a staggering 1% of all electricity on Earth. And that number isn't just growing, it's growing exponentially. This is creating a huge energy bottleneck that is literally threatening to slow down the entire AI revolution. So, this power shortage forces every AI company into a really tough spot. They have this critical dilemma. Do they use their limited energy for training, which is what makes their AI models smarter for the future, or do they use it for inference, which is what actually run the AI and, makes the money today? The problem is, you can't really do both at full throttle. So, how in the world do you solve a problem like that? Well, the solution on the table is pretty radical. It's basically, don't just try to win the AI race. Own the entire racetrack, from the asphalt to the grandstands. You can think of the AI world right now as being split in two. You've got the armies. These are companies like OpenAI and Google, the ones building the actual AI models. And then you have the bullet makers, like NVIDIA, who supply the critical hardware, the chips. The strategy we're looking at today is to be both. Be the army and the one making all the bullets. And this is the crucial point. We're talking about controlling every single component. The AI models, sure, but also the custom-designed chips, the memory, the packaging, even the power plants and the cooling systems. It's the whole shebang, a completely self-contained ecosystem. Now, this strategy isn't just about owning all the parts. It's about creating this unstoppable momentum. It's designed to spin up 6 different feedback loops, or flywheels, that all reinforce each other and just keep accelerating. And here's how it all connects. It kicks off with a loop where better software helps you design better chips, which then leads to better ways to manufacture those chips. All of this is supercharged by having more and more energy, which is funded by a huge money flywheel, and the entire thing gets more efficient because of revolutionary factory engineering, you see? Each part makes every other part stronger, and the whole thing just spins faster and faster. Okay, this is where it gets really interesting. This is where the strategy directly attacks that core energy problem we talked about earlier. It's a brilliant two-pronged approach to unlock what is essentially unlimited AI compute power. So, while all the competitors are basically fighting for a bigger slice of the same old energy grid, this plan just kind of sidesteps the whole fight. It taps into 2 vastly larger sources. First, a distributed network of computers right here on Earth, and second, absolutely massive solar-powered data centers up in space. And this just perfectly illustrates the difference. Traditional data centers, they're stuck. They depend on the grid, they have physical limits. But this new model, it taps into unused peak power on Earth, power that's generated but goes to waste, and it taps into unlimited 24/7 solar power up in orbit. So how much power are we really talking about here? By using millions of Tesla cars and bots as one giant distributed computing network, this system could theoretically tap into 50% of the world's total peak electrical capacity. That is an unbelievable amount of energy. And if you thought that was wild, that's just on Earth. In space, the potential is, well, it's astronomical. With huge solar-powered data centers, we could be looking at 1,000 times more electricity than we use today, which could translate to something like 100,000 times the AI compute capacity we have right now. It's almost hard to comprehend. So what's the end game here? What happens when you own the entire stack and you have access to nearly infinite energy? Well, you get a truly decisive and maybe even an uncatchable advantage. For starters, it completely gets rid of that painful choice between training and inference. It's not a dilemma anymore. The ground-based data centers can be dedicated 100% to just one job: training, making the AI smarter and smarter faster than anyone else. Meanwhile, that huge distributed network and the space network can handle all the inference, the part that actually makes money, without any limits. And we're already seeing hints that this kind of technological dominance is possible. Just look at SpaceX's upcoming direct-to-cell service. It's projected to have speeds that put it right up there with established ground-based 5G providers like AT&T. This just proves that the capability to execute on this ridiculously high level is already there.
And that leaves us with one final and pretty provocative thought. If a vertically integrated strategy on this scale actually works, if it solves the fundamental energy and compute bottlenecks, it could create a lead in artificial intelligence that isn't just significant, it might be literally insurmountable. So you have to ask, what happens next?